today we're going to talk about the arithmetic mean, the geometric mean, the weighted mean, and the harmonic mean. In addition to that, the root mean square formula as well. So if you want to calculate the arithmetic mean, or if you want to find the average, what we need to do is take up the sum of a series of numbers and divide it by the number of numbers that you have, or the number of observations. So this would be like x1 plus x2 plus x3 all the way to xn divided by n. So that's the formula to calculate the arithmetic mean. Now let's say if we have an arithmetic sequence. Let's say we have the numbers 2, 5, 8, 11, 14, 17, and 20. The first term is 2, the second term is 5, the third is 8, and so forth. Each term is separated by a common difference of 3. Now it turns out that if we were to take the arithmetic mean of this sequence, if we were to add up the values A1, A2, A3, A4, all the way up to A7, and divide it by 7, this is going to give us the middle term in the arithmetic sequence, which is going to be the fourth term, 11. If you have a sequence with a common difference, then you have an arithmetic sequence. So let's calculate the arithmetic mean of this sequence. So it's going to be 2 plus 5 plus 8 plus 11 plus 14 plus 17 plus 20. And we have 7 observations, or 7 numbers. So let's divide that by 7. So the sum of the 7 numbers that we have is 77. And 77 divided by 7 is 11, which gives us the middle term. So that's a quick and simple way to find the arithmetic mean of a set of numbers. Now, notice what happens if we find the arithmetic mean of the first and the third term. The arithmetic mean of 1 and 3 is 2. 2 is the middle number of 1 and 3. So this is going to give us the second term. So if we were to average 2 and 8, this would be 2 plus 8 divided by 2. 2 plus 8 is 10. 10 divided by 2 is 5. That will give us the middle term. Likewise, if we were to take the arithmetic mean of the first term and the fifth term, we will get the term in the middle, which is the third term. So let's average the first and the fifth term. The average of 1 and 5 is 3. 1 plus 5 is 6, divided by 2 is 3. So this will give us the third term. So a sub 1, the first term is 2. A sub 5, the fifth term is 14. And let's divide that by 2. So 2 plus 14 is 16. 16 divided by 2 is 8, which gives us the third term. I want you to understand this process and how the arithmetic mean relates to an arithmetic sequence. So if we want to find the arithmetic mean of the second term and the seventh term, we're going to get the term in the middle, which is going to be, actually let's do the third term and the seventh term. The term in the middle is going to be the fifth term. So we should get 14. So A3 plus A7 divided by 2. The average of 3 and 7 is 5, so we should get the fifth term. A3 is 8, A7 is 20. 8 plus 20 is 28. 28 divided by 2 is 14, which equals A sub 5. So that's how the arithmetic mean works in an arithmetic sequence. Now let's move on to the next topic, the geometric mean. So let's start with a geometric sequence. Let's say we have the numbers 3, 6, 12, 24, 48, 96, 192. First, I want you to see the difference between an arithmetic sequence and a geometric sequence. So going back to the arithmetic sequence that we had before, to go from the first term to the second term, we need to add 3. So the common difference is 3. To get each successive term, you have to add 3. With a geometric sequence, you're dealing with multiplication. Instead of a common difference, you have a common ratio. In this case, the common ratio r is 2. We need to multiply by 2 to get the next successive term. So that's the defining characteristic of a geometric sequence. Now you might be wondering, what is the geometric mean? So recall that taking the arithmetic mean of 2 and 8 gave us the middle number 5 in the arithmetic sequence. What just happened there? Taking the arithmetic mean of 2 and 14 gave us the middle number in the sequence, which is 8. The same is true for finding the geometric mean in a geometric sequence. So this is a sub 1, a sub 2, a sub 3, a sub 4, and so forth. The geometric mean of two numbers is the square root of the product of those two numbers. So if we want to find the geometric mean of, let's say, a1 and a3, we're going to get the middle term, a2. So a1 is 3, a3 is 12, 3 times 12 is 36, the square root of 36 is 6, which is the value of a2. So let's say if we want to find the geometric mean of a1 and a5. The middle term between a1 and a5 is a3. So we should get that answer. a1 is 3, a5 is 48. And I'm going to use a calculator for this. 3 times 48 is 144, and the square root of 144 is 12, which is the value of a3. So that's how you could find the geometric mean between two numbers. You could simply use this formula. It's the square root of the product of those two numbers. But now sometimes you may want to find the geometric mean of many numbers, not just two. In this case, you could use this formula. It's going to be the product of those numbers, x1, x2 times x3 times x4, all the way to x sub n raised to the 1 over n. So let's say we want to find the geometric mean of these 7 numbers. By the way, so this formula comes from this equation, because if you have just the two numbers, the first two data points, this would be x1 times x2, and since we have two numbers, it's going to be 1 over n or 1 over 2. And when you raise something to the 1/2, it's the same as finding the square root of that thing you're looking for. So these two formulas are identical, but if you have multiple data points, then this equation becomes extended. So x1 is 3, x2 is 6, x3 is 12, and so forth. And we'll go all the way to 192. So we have 7 numbers here, so we're going to raise this to the 1 over 7. So 3 times 6 times 12 times 24, all the way to 192. I'm just going to do this one step at a time. I get 4, 5, 8, 6, 4, 7, 1, 4, 2, 4. And I'm going to raise that to the 1/7 power, and I get 24. Notice that this is the middle term in the geometric sequence of 7 numbers. So when I took the arithmetic mean of the first 7 terms, I got the 4th term because that's the middle term. Likewise, taking the geometric mean of all 7 terms in the geometric sequence gave us the middle term of that sequence, which is the 4th term. So I want you to see how the arithmetic mean, how it works in an arithmetic sequence, and how the geometric mean works in a similar way when dealing with a geometric sequence. But this is the formula that you want to use to calculate the geometric mean if you have many data points. If you just want to find the geometric mean of 2 numbers, you could simply use that formula. Now let's move on to the next topic. So let's talk about how to calculate the weighted mean or the weighted average. Here's the formula that you can use to calculate it. So the weighted average is going to be the sum of the products of the respective weight, which typically will be like a percentage, times the x value. And then once you add those up, we're going to divide it by the sum of the weights or the percents. Another way to see this formula would be like this. So W1 x1 plus W2 x2 plus W3 x3 and then plus Wn xn. All of this is going to be divided by W1 plus W2 plus W3 all the way to Wn. Now typically you'll see this formula. It's going to be used for situations like calculating the center of mass. That's basically a weighted average. Or calculating the acid concentration of a mixture. Or even, let's say, average atomic mass. Those are some topics in chemistry and physics where you would typically use the weighted mean to get it. But what I'm going to do is use the example of the acid mixture. So let's say if we have solution 1 let's say this is a sodium chloride salt solution, and the concentration, let's say it's 20% salt, and the volume of the solution is 150 milliliters. And what we're going to do is we're going to mix it with another solution, but with the same substance. So this is another sodium chloride solution. This one's going to be more concentrated, so it's going to be a 40% solution, but the volume is going to be lower. So we only have 50 milliliters of solution, but we're still dealing with the same substance, sodium chloride. If we were to combine those two to form a larger solution, basically if we just mix those two together, what will be the concentration of the new solution? The identity of the solution will still be the same, but what's the new concentration? We know that if we add 150 milliliters of liquid with 50 milliliters of liquid, the total amount of liquid that we will now have is 200 milliliters. But what will be the new concentration? In this case, we could use the weighted average formula. So let's start with this formula again. We know W1 x1 plus W2 x2 divided by W1 plus W2 will give us the weighted average of x. In this problem, x is going to be the concentration. The weight is going to be the volume. So it's going to be C1 V1 plus C2 V2 over V1 plus V2. So W1 corresponds to V1 and C1 corresponds to X1. So we're going to get the new weighted concentration, or basically the concentration of the new solution. C1 is 20%, V1 is 150 milliliters, C2 is 40%, V2 is 50 milliliters, divided by V1 plus V2, that's 150 plus 50, which is 200. So the unit milliliters will cancel, giving us the final concentration as a percentage. So 20 times 150 is 3,000, and 40 times 50 is 2,000, so that gives us 5,000 on top, divided by 200. If we cross out the two zeros, this is 50 over 2, which is 25. So the concentration of the new solution is going to be 25%. So notice that if we were to average 20 and 40, we would get 30%. But these solutions, they don't have the same weight because this solution has more volume. Therefore, it's going to have more weight in this problem. This solution has less volume, so it's going to have less weight. So notice that the average, 25%, is closer to solution 1 than solution 2 because we have more volume of solution 1 than solution 2. So that's why the weighted average is closer to 20% than it is to 40%. Now, if we had equal volumes of both solutions, 100 milliliters each, the weighted average will be 30%. It will be right in the middle. But because these two have different weights, the regular arithmetic mean formula won't work here. We need to use the weighted mean because the weights are different. In this case, the volume represents the weights. So anytime you want to find the average of something where not each data point they're not equally weighted, you need to use the weighted mean. If you want to find the average of a set of numbers and each number in that set are equally important, they have equal weights, then you could just use the regular arithmetic mean formula. But if the weights are different, you need to use the weighted mean formula. Now, let's move on to the next topic. Let's talk about the harmonic mean. Now, before we go over the harmonic mean formula, let's briefly review the arithmetic mean formula. We know the average is going to be the sum of all the data points divided by n. Or in other words, to find the arithmetic mean, we can add up all of the x values, x1 plus x2 plus x3, all the way to x sub n, and then divide that by the number of observations. To calculate the harmonic mean, we need to take the reciprocal of the way in which we would calculate the arithmetic mean. So let me show you what I mean. So instead of summing all of the x values, we will take the sum of the reciprocal of the x values. Now once we have the sum, we're going to divide it by the number of observations. In the calculation of the harmonic mean, we need to do the same thing. Once we have the sum of all of the reciprocal of the data points, we're going to divide it by n. Now there's one additional step. With the harmonic mean, we need to take the reciprocal of our final result, or raise it to the -1 power. Which means you could rewrite the formula like this. So if we were to flip this fraction by applying the -1 exponent, it becomes n over the sum of the reciprocal of the data points. So this is how you would calculate the harmonic mean. But I wanted to show it to you this way so you could see how it relates to the arithmetic mean formula. So if you want to calculate the harmonic mean of multiple data points is going to be n divided by 1 over x1 plus 1 over x2 plus 1 over x3 all the way to 1 over xn. So this equation is simply the expanded form of that equation. Now, earlier in this video, we talked about how we could use the arithmetic mean formula to calculate the middle term in an arithmetic sequence. And we could also use the geometric mean formula to calculate the middle term in a geometric sequence. Well, it turns out that it works the same way with the harmonic mean formula. You could use that formula to calculate the middle term in a harmonic sequence. So let's say if we have the sequence 1 over 2, 1 over 5, 1 over 8, and so forth. Now notice that the denominators of these fractions, if you just look at the numbers 2, 5, 8, 11, 14, 17, they form an arithmetic sequence. But once you take the reciprocal of the data points in an arithmetic sequence, what you now have is a harmonic sequence. So this is a sub 1, a sub 2, a sub 3, all the way to the 7th term. Well, we should probably use a different letter than a, because a usually is associated with arithmetic. So since this is not an arithmetic sequence, it's a harmonic sequence, let's use h sub 1, h sub 2, and so forth. I probably should have used g instead of a for the geometric sequence, but you could change that, if you want to. Now, if we want to take the arithmetic mean of two numbers, we know it's the sum of those two numbers, a plus b, divided by those two numbers. So instead of writing n, we could just write 2. If we want to take the geometric mean of two numbers, it's the square root of a times b. And this has the index number 2. Well, if you want to take the harmonic mean of two numbers, it's going to be 2 over 1 over a plus 1 over b. So going back to this formula where the harmonic mean is n over the sum of 1 over x, if we have two numbers, n is 2, and then this is just 1 over x1 plus 1 over x2. So as you can see, these two formulas are the same. It's just instead of x1 and x2, I'm using a and b. So this is how you would find the arithmetic mean of two numbers. This is the geometric mean of two numbers, and this is the harmonic mean of two numbers. Let's use this formula to see how we can get the middle term for the harmonic sequence above. So if we want to find the harmonic mean of the first and the third term, this is going to be 2 over 1 over h1 plus 1 over h3. And this should give us the value of the middle term h2. So let's do it. h1 is 1/2. So we have a 1 and then divided by h1, which is 1/2, so 1 over 1/2. h3 is 1 over 8. So you can plug this in your calculator, or we can use some algebra to simplify it. I'm going to multiply this fraction by 2 over 2. 2 over 2 is 1, so multiplying this fraction by 1 doesn't change the value of that fraction. I'm going to multiply this one by 8 over 8. So 2 times 1/2 is 1, and this just becomes 2 times 1, which is 2. 8 times 1 over 8 is 1, so this becomes 8 times 1, which is 8. So we get this. 2 plus 8 is 10, and 2 is 2 times 1. 10 is 2 times 5. We can cross out a 2, and we get 1 over 5. And as we can see, 1 over 5 is the value of h2. So we could use the harmonic mean formula to find the middle term of a harmonic sequence. Let's do one more example like this, and then we'll do it for the whole sequence. So let's say if we want to find the harmonic mean between these two, h2 and h6, we should get the middle one, h4. So it's going to be 2 over 1 over h2 plus 1 over h6, which should give us the value of h4, the middle term. So h2 is 1 over 5, h6 is 1 over 17. So I'm going to multiply this by 5 over 5 and this one by 17 over 17. So 5 and 1/5 will cancel, 17 and 1 over 17 will cancel. So I'm going to get 2 over 5 plus 17. 5 plus 17 is 22. And 22 is 2 times 11. So this reduces to 1 over 11, which is h sub 4. So the harmonic mean formula can help you to find the middle term in a harmonic sequence. Now let's calculate the harmonic mean for all of the 7 data points that we have here. If we do it for all 7, we should get the middle term h4. So this is going to be n over the sum of 1 over x. So we have 7 data points. And this is going to be divided by 1 over, so x1 is this whole thing, which is the same as h1. So 1 over 1/2 plus 1 over 1 over 5 plus 1 over 1 over 8, all the way to 1 over 1 over 20. 1 divided by 1/2 is just 2. 1 divided by 1 over 5 is 5. 1 divided by 1 over 8 is 8. And the last one's going to be 20. So if we were to add these, 2 plus 5, which is 7, plus 8, that's 15. And then that's going to be 15 plus 11 is 26. 26 plus 14 is 40. This is 60. This is going to be 77. And 7 is 7 times 1. 77 is 7 times 11. So this is going to reduce to 1 over 11, which gives us the middle term. So that's how you could use the harmonic mean formula to get the harmonic average. Now let's consider a situation in which we can apply the harmonic mean formula. So let's say we have 2 points, point A and point B. And let's say these 2 points are 800 miles apart. Actually, let's make that 400 miles. And let's say we have a car, which I'm going to use a box to represent a car. As the car travels from point A to point B, it travels at a speed of, let's say an average speed of 80 miles per hour. So it's going pretty fast. Then once it reaches point B, it turns around and it goes back to point A, but at a speed of 50 miles per hour. So it's going 80 miles per hour east and then 50 miles per hour west. And in both cases, it's traveling 400 miles in both directions. What is the average speed of the car for the entire trip? How do you calculate the average speed in this case? Would you use the arithmetic mean formula to get an equal weighted average? Would you use the geometric mean formula to get a geometric average? Would you use the weighted mean formula to get a weighted average, or would you use the harmonic mean formula? It turns out that in this problem, you can't use the arithmetic mean formula because the time in which the car is traveling east is not equal to the time in which it travels west. So the weight that you would apply to each speed is different. So the arithmetic mean formula won't work. And this problem, I don't see it has any relation with a geometric sequence, so that's out of it. Now you could use the weighted mean formula and the harmonic mean formula to get the answer. But let's get the answer first using good old physics equations. Distance is equal to speed multiplied by time. Or you could say distance is equal to rate times time. We need to calculate the time first for each segment of the problem. Time is equal to the distance traveled over the speed. If you divide both sides by v, you get d over v for t. So if we were to take 400 miles during the first part of the trip, traveling at a speed of, the car's traveling at a speed of 80 miles per hour, if you divide these two, this becomes 40 over 8, which is 5. So during the first part of the trip, it took 5 hours for the car to go from A to B because the car is moving at a high speed. For the second part of the trip, it's going to take longer because it's moving at a lower speed. So the car is traveling the same distance of 400 miles, but at a slower speed of 50 miles per hour. 40 divided by 5 is 8, so this is going to it's going to take 8 hours to make the return trip at the slower speed. So because the time spent during each part of the trip is different, each of these speeds will carry a different weight. So we could use a weighted average to get the answer. Now to get the average speed, we need to take the total distance and divide it by the total time, which it really comes back to this formula, d equals vt. Solving for v, you need to divide both sides by t. So you get that v is d over t. So the total distance traveled, 400 miles east, 400 miles west, that's 800 miles. And the total time is 5 plus 8 is 13 hours. So using good old physics formulas, 800 divided by 13, that will give us an average speed of 61.538, I'm going to round that to 54 meters per second. Now what we want to do is we want to use the weighted mean formula and the harmonic mean formula to get the same answer. So let's start with the weighted mean formula. We know the average x value is going to be the weight times x1 plus the weight of x2 times x2 divided by the sum of the weights. Now the weights could be different things. For the acid mixture problem, the weight was the concentration. For this problem, the weight is going to be the time that the car spends going at the different speeds. Because remember, we want to average the speed. In this formula, we're trying to find the average x value. In this case, x represents the speed. So if we were to replace x with v, we would get the formula like this. The time is the weight. So W1 corresponds to T1 and X1 corresponds to V1. So this would be, you could say T1 V1 or V1 T1, the order doesn't matter. So this will be V1 T1 plus V2 T2 divided by T1 and T2. So time is what determines the weight of each speed in the average speed calculation in its formula. So V1 is 80 we're going to multiply that by 5. V2 is 50. We'll multiply it by 8, and then we'll divide it by the total time, T1 plus T2, which is 13. So we have 80 times 5 plus 50 times 8, which is 800 divided by 13, and that will give us the same answer, 61.54. Now you can also do it this way too. You could find the average velocity, the average weighted velocity, by taking V1 and multiplying it by T1 divided by the total time, plus V2 times T2 divided by the total time. When you take T1 divided by the total time, you're going to get the decimal equivalent of a percentage. So this tells you the percentage of the total time that the car is traveling at 80 miles per hour, and this gives you the percentage of the total time as a decimal that the car is traveling at 50 miles per hour. So this will be 80 times 5 over 13 plus 50 times 8 over 13. Now I'm going to get the decimal equivalent of 5 over 13. So you could understand it from a percentage viewpoint. So 5 over 13 is 0.3846. And 8 over 13 is 0.6154, interestingly. So if we multiply 80 by 0.3846, and then add that to 50 times 0.6154, you're going to get the same answer of 61.54 meters per second. But I want you to understand what this means so you could see it as a weighted average. So about 38.5% of the time, the car is going at 80 miles per hour. And around 61.54% of the time, or about 61.5% of the time, the car is traveling at 50 miles per hour. If we were to take the arithmetic mean of 50 and 80, this would be 65. But notice that the average speed is lower than the arithmetic mean. Why is that? Why is the average lower than the arithmetic mean? The average being 61.5, the arithmetic mean being 65. The reason is this car spends a longer time at the lower speed. It spends a shorter time at the higher speed. So the lower speed has more weight in this problem because the car spends 8 hours at 50 miles per hour, but it spends a shorter time of 5 hours going at 80 miles per hour. So because it spends a longer time going slower at 50 miles per hour, the average speed is going to be closer to 50 than it is to 80 because 50 has more weight. It has more time weight in its problem. So that's why we got this average 61.54, which is closer to 50 than it is to 80. Is because 50 has more time weight than 80. So that's why I wanted to express it this way. So you could see the percentage of the time at which the vehicle is going at, the two different speeds. So 61.5% of the time it's going at 50 miles per hour, and 38.5% of the time it's going at 80 miles per hour. So the average is closer to 50 than 80. Now let's get the same answer using the harmonic mean. So here is our harmonic mean formula. And we are averaging two numbers, so n is 2. And this is going to be divided by 1 over h1 plus 1 over h2. But in this case, h is going to be v, since we're averaging the speeds. So I'm going to rewrite the formula this way. So the average velocity using the harmonic mean formula is going to be 2 over 1 over v1 plus 1 over v2. So 2 divided by 1 over, the first velocity was 80, the second velocity was 50. Now we could use a calculator to get the answer, but let's do some algebra here. Whoops, did not mean to do that. So I'm going to multiply the top and bottom by the product of the two denominators, so 50 times 80. 1 over 80 times 50 times 80, the 80s will cancel, leaving just 50. And 1 over 50 times 50 times 80, the 50s will cancel, leaving 80. On the top, we have 2 times 50, which is 100, times 80. 50 plus 80 is 130. And 100 times 80 is 8,000. So this becomes 8,000 over 130. Crossing out a 0, this becomes 800 over 13. And we've seen this fraction before. We know that 800 divided by 13 is 61.54. So as you can see, using the harmonic mean is a very quick and simple way to calculate the average speed of the car for that particular situation. So there's other applications of the harmonic mean formula. Average speed is just one of them. But you could look it up online as to what the other applications are. But this is just one of them that I wanted to go over, so you can see it in practice. Now let's talk about a different type of mean, the root mean square. So when I hear the word root, I think of square root. And when I think of square, I think of like squaring something, like raising it to the second power. It turns out that we're going to have both of those elements in this formula. So if you want to find the root mean square of x, if you see RMS as the subscript, that's root mean square. It's going to be the square root of the sum of not just the x values, but the square of those x values divided by n. So when you hear the word root, think of square root. When you think of square, think of x squared. So if we were to expand it, it will look like this. So it's going to be x1 squared plus x2 squared plus x3 squared all the way to xn squared divided by n. So let's say we have 5 numbers, 5, 8, 12, 16, 21. And we want to find the root mean square of this data set. So it's going to be 5 squared plus 8 squared plus 12 squared plus 16 squared plus 21 squared, all divided by n, which n is 5. So let's go ahead and plug this in. So 5 squared plus 8 squared plus 12 squared plus 16 squared plus 21 squared, that's 930. 930 divided by 5 is 186. And the square root of 186 is 13.638. So this is the root mean square of these 5 x values. So that's how you can apply the formula. Now let's say if we want to find the root mean square of just 2 numbers. So let's say we just have these 2. Let's say x1 is a, this would be a squared, and x2 is b, that would be b squared. So a squared plus b squared. If we have two numbers, n is going to be 2. So we get this formula for the root mean square of two numbers. It's a squared plus b squared divided by the two numbers, all in the square root. So let's put this together. We know that the arithmetic mean of two numbers is basically the sum of those two numbers, and n is going to be 2 since we only have two numbers. The geometric mean of two numbers is the square root of the product of the two numbers, with the index being 2. The harmonic mean of two numbers, it's 2 over 1 over a plus 1 over b. Now, there's a different form of that equation. If we multiply the top and bottom by ab, we get 2ab on the top. Here the a's will cancel, giving us b. And here the b's will cancel, giving us a. B plus a is the same as a plus b. So we get this other form of the harmonic formula. So you may want to write this in your list of equations. So the harmonic mean of two numbers is 2ab over a plus b. Now the root mean square of two numbers, which I'm just going to call r, that's equal, we said it's equal to the square root of the sum of the squares of those two numbers divided by 2. Now let's say that a is 10 and b is 20. Let's go ahead and calculate the arithmetic mean, the geometric mean, the harmonic mean, and the root mean square of those two numbers. So the arithmetic mean is going to be 10 plus 20 divided by 2. 10 plus 20 is 30. 30 divided by 2 is 15. So a is 15. The geometric mean is going to be the square root of 10 times 20. 10 times 20 is 200, which is the square root of 2 times the square root of 100. The square root of 100 is 10, so we get 10 root 2. So g is 10 root 2, which as a decimal, that is 14.14. Now let's calculate the harmonic mean. It's going to be 2, let's use the other formula, 2ab over a plus b. So that's 2 times 10 times 20 over the sum of 10 plus 20. 10 times 20 is 200 times 2, that's 400, over 30. So crossing out a 0, we get that the harmonic mean is 40 over 3. 39 over 3 is 13, leaving 1 over 3 remaining. So this is going to be 13.3 repeating. Now let's calculate the root mean square of those two numbers. So we have a squared, which is 10 squared, plus b squared, that's 20 squared divided by 2. 10 squared is 100, 20 squared is, 20 times 20 is 400. 100 plus 400 is 500, 500 divided by 2, we get the square root of 250. So 250 is 25 times 10, the square root of 25 is 5. So we get 5 root 10, which as a decimal, that's 15.81. So notice that the root mean square gives us the highest value. The harmonic mean gives us the lowest value. And so we could rank these four. So the harmonic mean is going to give us the lowest. The geometric mean, 14.14, that's between the harmonic mean and the arithmetic mean. And the root mean square is going to be the highest. So we have this pattern. H is less than G, which is less than A, which is less than R. Notice that the geometric mean is between H and A. It turns out that the geometric mean is equal to the geometric mean of the arithmetic mean and the harmonic mean. So A is 15, that's the arithmetic mean. The harmonic mean is 40 over 3. Now 15 is 5 times 3. And when we multiply that by 40 and 3, the 3's cancel. 5 times 40 is 200. And the square root of 200 is, well, 2 times 100. The square root of 100 is 10. So we get 10 root 2, which we can see that that's equal to G. So that's a formula you can add to your list. The geometric mean is equal to the geometric mean of the arithmetic mean and the harmonic mean. Now from that formula, we can get some other formulas too. So if we were to square both sides of this equation, we'll get G squared on the left, and the square root symbol will disappear. So dividing both sides by A, we get that the harmonic mean is equal to the square of the geometric mean divided by the arithmetic mean. Now going back to this equation, or this form of the equation, instead of dividing by A, we could divide it by H. And we'll get that the arithmetic mean is the square of the geometric mean divided by the harmonic mean. So if you know two of those means, you could find the other one. So that's it for this video. We've covered a ton of different means, and I just want to put all of these different ways of calculating the average all together in one video so you can see how they relate to each other. So that's it. I'm out. Thanks for watching, and hopefully you found this video to be educational.